So yeah, as David mentioned, I was the lucky winner two months ago, I think. And I'd like to thank the Python user group in San Diego and JFrog for this prize. And as a thank you, I'd like to give a small presentation. So this picture is, well, first I want to mention that all my talks, I have them on GitHub at this address here. And you can find this presentation as well. So this is a picture of the front side. This is the real size of the CircuitPython. And as you can see, it's loaded with different electronics, sensors and LEDs, speakers. Starting from the top, there is this green LED on the left, which is on here. I should hold it this way. Can you see? I have turned off my background so you could see what I'm holding. I hope you can see it. I can't see myself. Let's see if I can see myself. So then there's an LED that you can turn on and off. It's red, where you connect the USB, which serves both as a power and also as a connection to another computer. So it supports a serial interface to another computer. Flash memory that holds the astonishing number of 2 million bytes. That's where all your programs and all your library has to fit into that flash memory. And the controller itself, which is an ARM processor, a light sensor, a temperature sensor, 2 push buttons, a reset button in the middle, an infrared transmitter and a receiver that can also serve as a proximity sensor. It can reflect the infrared. Motion sensor and accelerometer, speaker that can make tiny little buzzing sounds, a microphone, 10 LEDs that are multicolor called NeoPixels, a battery connector. You can connect a pack of 3 1.5 volt batteries in series. That's 4.5 volt. And then we have 8 input-output pins. And then we can get current from 3 places that are distributed around. So here we have a ground, and here's 3.3 volt, another ground and 3.3 volts, a third ground. And here you have V out, which is just the current that you get through the battery. So, but because this is all packed with electronics, you don't need to actually connect anything to this board. You can do it. They are not really pins because they're made so that you can attach alligator clips to them. These pads can also serve as touch sensors. I tried it, didn't work, but I don't think I tried hard enough. So because you have all these electronics, you don't need to buy any electronics, you can start right away. And there are 3 ways or 3 programming languages that you can use. MakeCode, if you're familiar with Scratch, it's like little puzzle pieces that you can put together and they snap together and they make up code and they translate into JavaScript. Or you can use the Arduino IDE, and then what's most important for us is the CircuitPython. CircuitPython is an adaptation of MicroPython, and MicroPython is a smaller Python used for embedded programming. It's based on Python 3, but it doesn't have everything that a Python 3 has. If you go onto Adafruit's website, you will find lots of projects and code examples. So I'm going to give a small demo. So as you see, I already connected it. The little green LED is lit. And Adafruit recommends, well, when I have it connected first, I will have to show my file browser. You can see here, I have the Circuit Pi. It connects as an external drive. And on this external drive, I have these files. These files reside in the flash memory. And then I'm going to open Mu. Mu is the editor recommended by Adafruit. It has a Circuit Python mode. Great. And this file that is called code.py, that will run automatically once it's saved to the CPX, this device that I'm holding. So I'm not very good at coding in this IDE, so I'm going to use what I'm used to. So I have get this out of the way. So I have a small project here, the notebook that I was presenting from, and then my source files. I'm going to copy this and paste it into the Mu IDE, and then I'm going to save. As you can see, it starts blinking immediately as soon as I save. Simple loop turns the LED D13 on and off. And so it blinks at approximately 1 time per second. Another example. So it's, as you can see, it's very easy to get started with coding.
Can you show it's kind of not in the video, you actually Circuit Pi? Can you just lift it up?
I didn't get the question.
I mean, your device, it's not in the camera view, like we don't actually see that. It's, oh, okay, now we do.
Okay, I'm sorry. You have to tell me if you can't see it. I'm holding it up in front of me, so I'm hoping that you can see it.
Yeah.
So another one is this, what I call the little blue train. I'm going to copy that one. And save it. Can you see the device?
Hold it up higher, just a
Yeah,
little.
hold the high. Yeah, okay, yeah, that's good.
Hey.
So again, an infinite loop that turns the LEDs on and off. So what if I want to do both at the same time? There are 2 infinite loops. How do I combine the 2 loops? Imagine you have an LED that you want to toggle every 300 milliseconds, another LED that you want to toggle every 500 milliseconds. You could have a loop counter, and if that loop counter is divisible by 3, you toggle the first LED. If it's divisible by 5, you toggle the second LED. And if it's divisible by both 3 and 5, you toggle both LEDs. Well, that's very complicated. So I'm going to show you how I did that. So here's my blue train again. I have a function. So I moved on to using function. If you are new to programming, this is where you learn functions. And all the function does is to do one loop. And then I have an event queue, and I can push this function to the event queue. I push a pair. The first element in this pair is a time when it should be called, and the second is the function that should be called. There is a function that is distributed with CircuitPython that is called uheapq, which is the same as heapq in standard Python, but it's not distributed with CircuitPython for the CPX. And the reason apparently is that somebody has decided that if you're not doing Bluetooth, you don't need a heap. So I searched for it in the libraries that you can download for the Circuit CPX, and couldn't find it, so I just implemented my own. And so here's my implementation. And there is a file called mpycross, which is the cross compiler. So I can apply that cross compiler on this Python file, and I will get this uheap mpy. And I can then move it to, first let me copy it. Copy. And I can copy it into this lib folder. Where is paste? There. So now, sorry. So now I can, I can run this. Notice that I have a print statement, and there's no screen on the CPX. So what I can do, I can bring up the serial. And what I'm doing is I'm printing the timestamp every time it has completed one full round trip. I'm going to stop this. And if you see here, that it takes a little bit more than a second, although it takes just 1/10 of a second to move it. It should take exactly 1 second if nothing else took up any time. So I could tweak this variable here, shorten it so that it would take approximately 1 second, but that's quite time consuming. I'm going to show you my demo 3. And it's almost the same, except that now my function takes an argument t, which is the time that it should have been called. And then I schedule it for 100 milliseconds. Instead of using seconds, I'm using nanoseconds as unit. There is a time.monotonic_ns, which is the nanoseconds. And I do everything in nanoseconds because those are ints, and it's easier to handle ints than floats, I find. And so if I run this, you see it, there's no more drift. It takes exactly 1 second for each rotation. And then now I can run both at the same time. Yeah. So in order to run both at the same time, I put all three. I have three functions: one that moves the train, one that turns the blinking on, another that turns it off. And then I put two of these functions on the heap, on the event queue, and I put them 1 nanoseconds apart. And the reason is that when Python compares tuples, if the first element and the tuple are the same, it will compare the second element, and you can't compare functions, so that's going to crash. So I make sure that the first elements in each tuple are distinct. And then if I save this, now it's both rotating and blinking at the same time.
Can you hold it up again so we can see? Ah, there we go. Hey.
So being able to do more than one thing at the same time is important. There are no hardware interrupts, so you can't use that. You have to, if you're going to, for instance, sense when the push buttons are pressed, you have to poll. You have to check their state every so often. Now, if I could stop this, Control C. Says press any key, that's a space key, and I enter the REPL. And if I do import threading, that would be the natural way of doing it, but there's no such module. Import async IO. You can't do anything of that, so you have to create your own event loop. And so I hope I've demoed how to play around with the Circuit Playground Express, the CPX. It's fun. I could have done so many other things. I did something very trivial, but yeah, you can do, for instance, voice recognition. You have to train them on a big computer, and then once you've done the training, you can download the result, and it can recognize like simple yes or no, which is not quite cool. So that's what I had to present today.
Thank you. Any questions?
Sure. So is there a way to run it on it? So once you program it, like when you disconnect, is it like, does it run the last thing you loaded on it? Or is it
I didn't.
Like, is there any way to like program it and disconnect it and run it in disconnected way just to have a power?
Oh yeah, yeah. So if I go here to my, okay, you can't see my screen anymore. Let me disconnect it. It's disconnected now. And I get on my screen, it says I didn't eject it properly. I can just, as soon as I provide power, it's going to run the program that was last loaded. And so I could have put a battery pack instead, and it would just run the program that was last saved. Also has no electronics on the back side, so you could glue, for instance, a handle, and you can like make like a cool things.